All right, now that we can do an orbital diagram, the next step is taking that to be able to actually write an electron configuration. So writing an electron configuration is really straightforward if you can do this. So to write the electron configuration, first let me show you what this is. If you forgot, this is an orbital diagram for the element chlorine. We did that in class in the last class period. And if I want to show you what the electron configuration looks like for that, I am going to go to ptable.com. And when I am on ptable.com, I'm going to click on this little electron tab up at the top here. And when I do that, if I hover over chlorine, it says the orbital diagram right in the middle of the screen there. Like I said, I can't get out of there to go see it, but over here, here's sodium. Here is the electron configuration. It says 1s2, 2s2, 2p6, 3s1. So if I go hover over chlorine now, and then look at that same spot on the left, underneath the green box where it says chlorine, the expanded electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So if I were to go to my notes and write that, basically what I'm doing is I'm taking this 1s and I am writing 1s2. And then I would write 2s2, and what I'm doing when I'm writing 2s2 is when I say 2s2, I'm counting the electrons that are in the box. There's 1, 2 electrons in the box. So 1s2, 2s2, and then it would be 2p6 because there's 1, 2, 3, 4, 5, 6 electrons. So 2p6. And then 3s2, 3s2, because there's 2 electrons in the box. And finally 3p5, 3p5. So what I did instead of using the notes, I actually went to the textbook for the course. And if I scroll down a little bit here, you can see the exact same thing that I just did. Here is an orbital diagram. This happens to be an orbital diagram for carbon. So the orbital diagram has been done correctly, obeying all the rules. So when I want to do the electron configuration, 1s, count the arrows, 2, so that's 1s2, 2s2, and then 2p2. If I add up all these little numbers, that should be the total number of electrons. If I wanted to do an electron configuration for this, whatever this element is, we can figure that out in just a minute. It would be 1s2, 2s2, 2p, 1, 2, 3, 4, 2p4. So whatever element this is an element that has 1, 2, 3, 4, 5, 6, 7, 8 electrons. And it's probably oxygen, but remember you can't identify an atom based on electrons unless you're told that it's a neutral atom. It does say right up here that this is oxygen's orbital filling diagram. To emphasize this once again, if you do add up all these little superscripts, 2 plus 1 is 3, that's how many electrons there are. 2 plus 2 is 4, that's how many electrons there are. 2 plus 2 plus 1 is 5, that's how many electrons there are. So a really nice way to do this when you're trying to do electron configuration is to just simply find an electron configuration that's in a handout or a worksheet or something somewhere where you know that the order has been written right. This is like test taking strategy 101. So I'm going to go find one of those on the worksheet right now. So this is your homework assignment right here for today, where you're supposed to do some orbital diagrams and then write the electron configurations. You guys can cheat if you want. I mean, shoot, if you want to do magnesium, just go to ptable.com, hover over magnesium. Right in the middle of the screen is the orbital diagram, and to the left of the screen shows the expanded electron configuration: 1s2, 2s2, 2p6, 3s2. Just, you got write it down. I I wouldn't recommend doing that. It's not going to help you when you have to take a test or a quiz, but I mean, you can get all of the answers to this really easily. If I copy this very long configuration that was there and go back up, and let's just pretend for a minute that I want to do these configurations. This is a great test taking strategy where I'm just going to pop that in there. I know magnesium, by looking at a periodic table, has 12 electrons. I know that. So if I want to know what it is, I can go 1s2, 2s2, 2p6, 3s2. I don't need any of these electrons written there, so I'm just going to delete those. And that's the electron configuration for magnesium, because when I add up all the superscripts, I get up to 12. If I want to do oxygen, I can use that same strategy. I can paste in a really long one or find a really long one somewhere on the test, somewhere in your homework. And then let's see, well, oxygen, I got to get up to 8 electrons. So 2, 4, in this 2p area, I don't need all 6 of those because that's 10. So oxygen would go up to 2p4. And I don't need all of this there. I got my oxygen one done. I have the right number of electrons in it. If I want to do aluminum, once again, I could paste that very long electron configuration in. Aluminum happens to have, when I look at ptable.com, aluminum has 13 electrons. So, I mean, I could cheat right there. I got the orbital diagram written. I got the electron configuration right over there on the left. But I'm trying to make sure I know how to do this on a test or quiz. So, aluminum, I got to get up to 13 electrons. 2, 4, 10, 11, 12. The 13th electron is going to be in that 3p6 area. But I don't need all 6 of them. I only need 1. Because right now when I add these up, 2 plus 2 plus 2 is 6, plus 6 is 12, and the 1 is 13. So that's a really super easy way to figure out what an electron configuration is when you have to do that on a test or a quiz. The skill right below it, this is actually quite easy. Just add up all the exponents, and that's going to be the element. Just add up all the exponents. 2 plus 2 plus 6 plus 2 plus 6 plus 2. That's going to be calcium. So you really do have the skills that you need at this point to be able to do this homework assignment. I mean, that's it. That's a real quick and easy way to do electron configuration. I am going to, though, show you something really slick. So you can use the periodic table as a key to figuring out electron configuration. If you don't have a really long electron configuration sitting around somewhere, or if you don't have a way to do the diagonal rule so you can reproduce the electron configuration, just looking at a periodic table will help you. The periodic table, when it was designed, is actually laid out really, really kind of neat, where these ones over here, these pink ones, if you look at the key, that's your S block. So this is 1s1. What I want you to do is I want you to focus right here, right now. This is your 1s1, this is your 1s2. This is your 2s1, this is your 2s2. This is your 3s1, this is your 3s2. And you can see those right down here where it says 3s1. So all of these are s1s. All of these are s2s. So if somebody says, hey, what's the element with the configuration 1s2, 2s2, 2p6, 3s2, if it ends with 3s2, that's all I have to look at, is I have to look at the third row, and I'm going to go past s1 to get to s2, and that would be magnesium. Magnesium would be something that ends in 3s2. So again, looking at your homework assignment, if I have to identify some of these down here, like in question number 3, I need to find a 3p2. So if I'm trying to find a 3p2, I'm going to be in the third row. I have to get to the p block, which the p block is over here. So this is 3p1, and the next one is 3p2. And then 3p3, 3p4, 3p5, 3p6. But 3p2 is right there. That's silicon. I have a really nice like cheat version of a periodic table that can be handed out to you that you can use when you're doing this particular part of the assignment. It looks like this. And if you have this, it's really nice to be able to do that particular assignment that you're supposed to do. So I'm going to find the element that ends in 4p5. If I'm trying to find the element that ends in 4p5, well, I can look at this periodic table. I'm going to go to the 4p area of the table. So it's right here. And 4p5 is this one. So once I know where that is on the periodic table, I can then correspond to a real periodic table and find that same element. That's going to be bromine. Bromine is going to end in 4p5. And if you look over on the left at the box where bromine is, underneath it, it says the expanded configuration. There is the 4p5 configuration. It's a really nice way to view it, to view the periodic table. You can just simply go through and find any of the elements that you need there, and then write them down.